Hi, welcome to Tech Ranch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation, binary tree traversal. Today we are presenting you a live demonstration and implementation of traversal of binary tree data structure using Java. Before we get into the demonstration and implementation, let's first learn what is actually a tree. Tree is a kind of a data structure which stores the data in hierarchical manner. That means the data in this kind of data structure is maintained in a layered form, level form, in a hierarchy. Each data element is stored in a structure called a node. So this is what we call a node. Example, you can see the tree T1 that has root node A, that called root. A's child nodes or parent node are B, C and D, as you can see here. Next layer of BCD's child node are E, F, G, H, I, and these nodes are called grandchild nodes or leaves nodes. Length of this path of this tree or number of branches, as you can see in the layered form in a hierarchy, is 2 edges. So first layer is between A to B and second edge is between B to E. So this is what the layered or hierarchy. Now this is about the tree. There are two types of trees. One is linear and another is binary. So in this session we are going to cover about binary tree data structure. Binary tree is a kind of a tree data structure which has at most 2 children. Since each element in a binary tree can have only 2 children, they're named as left child and right child. So as you can see, this is a structure. Here is the root and this is the level 0 and next level is 1 and that has B and C. So A has 2 childs. One is right and another is left. So this is how it differentiate the right and left on their side. And further in the next level or next hierarchy, you can see their parent node D, E, F and G. They are siblings. It's just like a family tree. We have a grandchildren, grandparents and grand root of the family. So this is how it goes, and we have the another subtree. You can see that is also another kind of terms you can use some places. When we traverse or when we actually work in binary tree, it will be more clear. So binary tree has at most 2 children. It is not necessary that every node has 2 children. As you can see, E and J has only 1 child. So it is mentioned as at most 2 children. So that's what the binary tree is about. Now let's take a look at the tree traversal. Now tree traversal is a process to visit all the nodes of a tree and may print their values too. There are 3 ways which we use to traverse a tree, and that is in order, pre-order and post-order, that we'll see one by one. But to traverse these type of structures, they are mentioned in a depth first and breadth first types of traversal process. Now, traverse process based on depth and breadth is basically based on the level or the nodes based. So when you read the data structure, tree data structure based on the levels, so it starts from the bottom, like we are reading it 13, 15, 14, 34, 4, 40. So this is how we are reading from the level based. Now when we say the breadth based, that is basically according to the node based. So that traverse process starts from the node based. So here we can read it like 44, 45, 34. So this is how we are printing and traversing and visiting all the nodes of a tree data structure. Now let's take a look about the different types of process and different types of traversal process we have in our data structure. First is Inorder traversal process. So Inorder traversal process in a binary tree, we can mention it in such a way that where we are going to process 3 steps. And these 3 steps will further recursively executed until all the nodes are traversed. So first step, we have to check for the subtree, and the subtree has a left node. So we start from the left node of a subtree A and then B, and then we check another subtree. See, if he goes to the D and he check for another subtree, so it has a left. So he will read the C and then check the root, that is D, and then it will check the right, E. So this is how we go with the in order. We just remember the formula is left, root, right. Another type of traverse process is pre-order. Pre-order traversal is the same way, that it will traverse the entire tree until all the nodes are traversed. But here it starts from the root. So it will first visit the root node, that is 40, and recursively check for the subtrees and visit the left node. And if there is no left node, then it will check for the right node. And when it is a right node is there, then it will visit that node and then check further the subtree. And in this way, it will traverse the entire tree. So the formula for pre-order, the process is root, left, right. The another type of tree traversal is post-order. In case of post-order traversal, it will again do the same way. The recursively traverse all the nodes of a tree in the form is left, right, root. So post-order traversal will further traverse the entire all nodes of a tree recursively, and in the first step it will check for the left node of a subtree, and as you can see A, and then it will check for the right node of the tree, and if it has further subtree, then it will check again for its left node since it is C. So you can see A, and then it will check for the D, and then it will check for the left node C, and then check for the right, and then root. And further it will go to the root and then check for the right, and then right, and it will check for the left node, root, and then G and F. So this is what the post-order binary tree traversal. Now if you see the demonstration, we can have an example. So there is a tree mentioned like this. It's a binary tree, as you can see. All the nodes of this tree has 2 child nodes, and we need to execute it and implement it all the 3 traverse process. So in this case, like Inorder Traversal, it will check for the, so we'll take an example. There is a tree which is a binary tree. As you can see, it has 2 child nodes. All the nodes have 2 child nodes, and we are going to visit all of them and implementing in-order, pre-order and post-order traversal. So how it will print the values of this tree. So in case of in order, we have to see left, root and right. So this is our tree. There is a root and it has a subtree. It goes to the left side and it again has a, so it will present the 4, 2, root and right 5. And then back to the root and check for the next subtree and check for the left node 6, 3 and 7. This is your in order. In case of pre-order, root, left, right. Root is 1. Left is 2, and further it has left because it's a subtree 4 and 5, and then back to the root and traverse the entire subtree which is in the right side of the root. So this is 3, 6 and 7. This is your pre-order traverse. And similarly you have the post order. Here we can see left, right and root. So now let's take a look at the implementation. What we are going to do, we are going to have a class and we are going to create an object of a node and calling a constructor. Inside the constructor, we are going to create a root node. And once it is instantiated, then we can call all the methods, different types of methods for the post, in and pre-order, and calling it in the main method. Now let's code on. This is my Eclipse IDE. I'm going to create a different project. Named as binary tree traverse demo, and inside this project I'm going to create a package to make it more organized and structured. Mention binary.tree.demo, and inside this package I'm going to create a class binary tree traverse demo, and I need a main method. So this is my class. Let's start with the implementation. Before we start, we need to create a node. Since the node is basically your major element, major structure where we keep our data. So to retrieve the node, we need to have a key. We just use some variable, and that node has left and right. Since we have the two types of child of a node in a binary tree, we are going to make the constructor, so that will create an instance, and that constructor has a parameterized, that means it has an argument, it passing in parameter. Now inside the constructor, what we are going to do, we are going to assign the key, which is nothing but the item, and so get the value and assign it, and that is equal to right and left, and then assign it some variable null. So all the nodes is assigned to null to instantiate and create an instance of a node. So now once the node is created, next step, inside the class we need to have the node object of this class, and we creating the first thing is root. Now after this we need to create a constructor for this class to create an instantiate, to have an instance of this type of class, and here root is assigned to null. We need to assign a root node. Now once this is done, so we have created a root node on a tree. So first we have the tree, and then we have a root node in that tree, which is assigned to null, and that has right and left, that is also assigned to null. So let's start the implementation of Inorder Traverse. So for that, just have a void type of method and Inorder Traverse. And Inorder Traverse has an argument passed node, since we are going to traverse all the nodes. And this parameter, first we start with the node equals to null. So remember, Inorder Traverse is basically performing left node, then root node, and then right node. Left, root, and right. So first we need to have the node which is assigned to null. If it is null, then return. And once this is done, okay, our first node has to traverse is left node. So all you need to recursively call this method and call traverse the next left node. Right. Now once this is done, next we need to call your left, then root, and then right. So basically we don't have the root node right now, which is assigned to null. So we can have left node, and instead of root node, what we need to do is we need to print the key. So we are going to print the root node by printing the key value. And just having the some space. So whatever be the root node, your first assigned value is going to be a key. This is why we created our root node. Now this is how we implement our Inorder. Similarly, we are going to implement our preorder and postorder. The only difference is going to be there traversing the node. So let's give the name preorder, and the same argument structure, the same theory. Instead of this is our first. So first we need to have the root for pre, right? So root goes like this key, and then instead of Inorder we need to give preorder and method, and root preorder have the root and left and then right. So all you need to make changes is giving the method name different. And similarly for the postorder and For post order, we have left node, first left node, then right node, and then root. So this is how you can implement your methods for the traversing all the nodes, traversing process. Now we have implemented the method. Now we need to call these methods. For that, first we need to have the call these methods. We need to have the root started. So printing the root started, all you need to just call these method recursively and pass the parameter root. And just same thing for making a root method for inorder, preorder and post order. You see? So what will happen in this case? We are having a root node defined. So the user get the value from the main, and then from main we can have all the classes. Now let's define it in the main method. First thing, we need to create an object of binary tree class, demo class, binary tree traverse demo, just binary equals to new constructor. Now here binary dot, we are going to call root equals new. We have to create a node and give the value, some integer value, any random integer value. Now binary is the object of the tree, root dot. Now next is left. We have to keep making our own tree and insert the node. You see, some random value. So we can create as many as you want to create a, okay, binary dot root dot right. So you just picturize yourself that you are creating a node and entering the values, and this is the tree structure. So root node is 1 and that it has child, left child is 2 and right child is 3. Or give some value, not necessary the. Now next we need to create another, since you can create as many as tree you want to another subtree. You can implement this type of structures many ways. This is one of the simplest form we have tried here. So next we have to have the binary root left right, another subtree you need to finish, so we can give any name, new node 5. If you want to make more subtree you can have that too. And now just like this, binary dot root dot left dot left dot left equals new node 6 is just a sample, or binary dot root dot left dot right equals new node. We are creating a node and just give 7. You can give any numbers, that's not necessary. Now next step is we need to print all the trees traversing process. So for in order, first let's see in order traverse, binary tree traverse. You need to just call binary dot in order method and it will, this is supposed to be pre-order, so make it pre. Post order, okay. So when we keep our node class outside the main class, the node is considered as a separate class. Now let's take a look at the execution. So here is the execution. If you see, in order of a tree, we started from the left node, then root, and then right. To make it more simple to understand it, we can remove this one. So it will print with some space. In the sequence. Okay, it's mixed up a little bit. Let's put the slash in here. And now see the execution. So we have a tree structure of 1, 2, 3, 4, 5 in order binary tree traverse 6, 4, 7, 2, 5, 1, 3. That follows the in-order traverse. That means left node, then root node, and then right node. For pre-order, it will simple 1, 2, 4, 6, 7, 5, 3. That means root node, left node, and then right node. And for post order, similarly, left node, right node, and then root node. So this is a live implementation of binary tree traverse for in-order, pre-order, and post-order traverse algorithm. So we have seen the implementation. Now let's take a look at the important facts about binary trees. Trees, unlike arrays, linked lists, stacks, and queues, which are linear data structures, they are in a hierarchical data structures. One reason to use trees might be because you want to store information that naturally forms a hierarchy. Complexity of any operation to perform in binary tree, like search, insertion, and deletion, with n number of nodes, has a minimum of O algorithm of n node levels. So as many as nodes you have, that many types of levels you have, you can have the complexity of O algorithm n. Manipulate radical data. You can make information easy to search because we have to perform the traverse. That makes it a little easy. Manipulate sorted list of data. You can easily manipulate it as a workflow for compositing digital images for visual effects. Router algorithms, that makes the most useful and important feature of binary tree structures. Form of multi-stage decision making. You can check it out in the business, implemented and used in business chess and any other games, and any kind of algorithm you can implement in your business model. So this is all about the live demonstration and implementation of binary tree data structures. For any kind of assistance needed or source code or any kind of queries, questions, please provide your precious feedback and contact techcrunch2019@gmail.com. Thank you so much for watching this video. Please subscribe to our channel and stay tuned for more upcoming interesting and informative sessions. Let's make coding fun. Thank you.